Hey guys, happy Friday. Here's the last lesson of the week. It's our second lesson, this little, it's kind of an intermediate unit. We are working our way into understanding how chemical reactions work. But first, we're trying to figure out what are molecules made of and how do we read their chemical formulas and things like that. So, for you do now, we're building on things that we worked on yesterday. What is the atomic composition of this fancy looking molecule over here? So you might use this sentence starter. This molecule is made of. Tell me what is it made of. You might list the atoms in it. You might list how many atoms. You might list how many of each. You might tell me about how many elements are in it. A few different things you could tell me that could count as atomic composition. Put myself up here and we're looking at number 2. Then find your periodic table, and I'm going to try to remember to post one on your Google Classroom resources page. And what I want you to do is find what is the atomic symbol for neon and what is the atomic symbol for lead. Okay, I'm going to go ahead and pause and do that now. Okay, today I want to talk to you about our scientists of the day. Quick learning target and vocabulary. If you missed live class, and I will briefly go through what we did in breakout rooms and then explain your independent work to you. These are Christina Koch and Jessica Meir. They are American astronauts. They were on the International Space Station a year ago. Actually, some of them just came down, I think, in the spring. Christina Koch is an engineer, and Jessica Meir is a marine biologist and a physiologist, which means she studies the way our bodies work. And she's an aquanaut, which means she actually dives down and has trained to be a specific kind of diver that actually stays at underwater bases, which is really cool. So a year ago, these two went on a spacewalk outside the ISS. They are best friends, which is kind of cool. And it was the first time that it was an all-woman team. There have been women doing spacewalks for decades, since the 60s, I think. But this is the first time that two of them went out together. They were outside for over 7 hours. They fixed some stuff that was broken. And so when I say spacewalk, I like this picture. It's just them holding some cool looking drills. Let me get out of the way here. I mean this. This is when somebody is actually outside of the space station and they're attached to it. You can see this clip down here. So she is clipped in a couple of different places so she won't fly away and never be able to get back. But they're actually outside the space station in those suits you see them in, with the Earth behind them all the time doing work. The International Space Station goes around the Earth every 90 minutes, I think. And so for 45 minutes, they're in darkness because they're on the other side from the sun. And the other 45 minutes, they're in light. So they're doing this work for 7 hours, and every 45 minutes, they turn the lights off for 45 minutes. And it's dark. And so these lights on the side of her helmet light up. It's really cool. If you get a chance to see a live spacewalk, they do them a few times a year, and they're usually live on YouTube, and you can just watch them. And they happen, they're all day. They're 8 hours at a time, or longer. And so it's always really cool to see them. I like this picture because you can see her. I don't know who this is, which of them it is, but their friend is reflected here. There's one more picture here, which I think is just so cool. They actually pulled their visor up so you can see her face. I think it would just be the coolest thing ever to be up there in space, but close enough to the Earth that you're outside and all you can see it. You can see the Earth floating. Oh, just so cool. Okay, I'll stop talking about that. Today, our goal is to describe the atomic composition of simple molecules and something called extended structures. Remember, when I'm talking about composition, I'm talking about what are the parts that make up the whole. I might ask you about it. What is it composed of? And another example, yesterday we talked about lunches. Today, the example is a car. A car is made of tires. It's made of windshields and lights and engines, and there's different parts of the engines, and there's a bunch of different systems in a car, just like there's different systems in a person. It's composed of a lot of different things. Today we're talking about simple molecules and extended structures that won't be composed of nearly as many things. Okay, let's see. I can make myself small here and get out of the way. Yesterday during breakout room, we came up with rules. I basically typed those up for you, and these are what we came up with. We represent atoms when we're modeling, because remember this unit's all about modeling, we represent atoms as circles. These are atoms. To show a molecule, they can either be touching each other like they are down here, or connected to each other like here, or like these pictures show them connected. When they're connected, that shows that they're in a group. They're bonded together. You call that group of atoms a molecule. We can represent different elements, so different types of atoms, a couple different ways. We could just use colors like this picture here. There's red and white. That shows they're different. Or we could use the atomic symbol, O's and H's. O's and H's here. This is actually a relatively strange thing that the O's, the oxygen atoms, are not red and the hydrogen atoms are not white. Usually that is the case. You will see examples of that where we use just the colors, and we try to always keep them to that rule. When you're writing a chemical formula, so that's when you have like H2O. So in H2O, when there's only one atom of a certain element, there's only one O in a water molecule, only one oxygen. We don't write a number. We just leave it as O. And if there is more than one, we put the number after it. So H2O means H2 means two H's, O, and we don't say H2O1 because we don't need to. We can just say H2O and you know it's one. H2O means two H's, one O. Okay, we're gonna get lots of practice with that. So keep going here. So in the chat, I wanted to know which of these pictures do you think is an extended structure just based on that name, extended structure. You go ahead and think about that now, and I'll tell you, they're all extended structures. An extended structure is a very large molecule that has repeating subunits. And a subunit is just a piece that repeats over and over. If I go back up one slide, you can see that there's a red and a yellow piece, and they just repeat over and over. There's like a pattern. Here, it looks like a pattern as well. There's like one little puzzle piece here that's stuck together a bunch of different times. Here, the same thing. It's a pattern. You see the same pieces over and over again. Those are called subunits, and they repeat in what's called an extended structure. So sometimes atoms can combine to make things that are really big, not just like 5 atoms stuck together, but like really, really big. A lot of solids like plastic, crystals, things like that, can be extended structures, salt, sugar, metals, even organic things. So here's a picture of a diamond. Diamonds are carbon atoms only, just a bunch of carbon atoms stuck together. And you basically have a diamond is basically one big molecule. It's just one thing with trillions on trillions on trillions, of atoms stuck to each other in a shape like this. This is a DNA. Piece of DNA is an extended structure. It's just the same kind of thing, a backbone of DNA repeated over and over and over and over again, billions of times in your body. And salt. We'll talk about salt again later, but salt, look at these 2 different atoms just repeating over and over. It's really just 2 atoms repeated over and over and over. One crystal little thing of salt you might put on your food. In breakout rooms today, you have 3 slides to practice with. I want you to do these 3 slides with your group. It kind of gives you different things to do. For example, this is a picture of salt. The chemical name of table salt is called sodium chloride, NaCl. Is it a simple molecule or extended structure? Go ahead and highlight or circle one. And then what is its atomic composition? What is it composed of? Can you tell me what atoms or elements are in it? Tell me about that. The next slide gives you pictures of extended structures and some pictures of simple molecules. How are they similar? List a couple ways that they're similar. How are they different? List a couple ways that they're different. Finally, here's an example, or an example of a time that you get to data here, the full screen. You're going to get to model, which is very cool. So I have put some atoms over here, and in the atom bank, you can get just like we had a particle bank when we were showing particles bouncing around and stuff. So here's an example I did, H2O. You need to grab H's out of here, and if you need 2 of them, you can copy and paste 2. You can mess around with drawing lines if you want. Otherwise, you can just have them touching each other like this, and boom, I got H2O. Remember, if there's no number at the end, it means 1. H2O1, but we don't need to say 1. We just say H2O. What about NO3? Can you use these atoms, drag them, copy the ones you need to make NO3, which is nitrate? Okay, so that is the end of the breakout rooms. I would have given kids about 5-10 minutes to do that, maybe gone over it with them. And now here's your independent work for the day. You have 5 practice slides, 15 through 20. Slide 21 has your exit ticket. Here are your practice slides. Which sentence describes this substance? Look at the substance again. It's a diamond. Which of these sounds like a diamond with the picture? You got to use your periodic table. So you open this up. You can also now find it on your resources heading, your resources topic in Google Classroom. There's 2 periodic tables, this same one that's linked here, and also a PDF that you can have it open in your tab if you prefer that one. I want you to tell me the symbols, the letters for magnesium, plutonium, and chlorine. And then here are the symbols. What are the names of the elephants for this HGNATI? What is the atomic composition of this molecule? You have the formula, you have the picture. Tell me about it. Which picture matches the formula C3H8O? Which picture matches that? And which formula matches the picture of this molecule? So here is a picture of a molecule. Which formula matches it? And then here's 2 more molecules I want you to try to model using these given atoms. Once you finish all that, you're feeling pretty confident about it, take your quiz, 8 questions. You should always assume that your teachers are grading these if they're giving them to you. So do your best and expect it to be graded. That's it for today. I hope you guys have a great weekend. When you come back on Monday, we'll do a little bit more practice and we'll take a definitely graded final quiz. This is just a little mini unit, these 3 days. But then we use this skill now that we know how atoms and molecules work, and we can start looking at how do chemicals react with each other and change. So next week we start chemical reactions. Have a great weekend.